What's up, guys? Uh, made it through another week. It's week 7, right? It's week 7? 6 of RIT? My bad. Yeah, you guys made it through another week. Let's go. Um, announcements, right? Join the Discord. Once again, I ask, please join the Discord. It's a fun place. Okay. Please sign in. The sign-in's up this week, so please, I'll give you guys a second to sign in. Sign in so good. It's really cool, Caleb. You do it the best, Caleb, honestly, yeah. Okay. Check the calendar. This is how you know when all our events are. There's a bunch coming up. Please do that. Join the mailing list so you can get our sweet weekly newsletters. They're so good. They're so good. Thank you. It's the best. It's the best, honestly. Meet the sponsors. Clap it up. Let's go. Come on. Keep going. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah. And there's more, right? Yeah. Oh, yeah. Follow our social media. Oh, wait. Okay, there we go. Yeah, follow our social media. The Instagram is looking great right now. It's so good. The Twitter will be, popping very soon, but it's a good time. Okay. Unfortunately, Sophia's not here. But another announcement. Member Monday. Please nominate yourself or somebody else. Pretty much we do a weekly posting of a featured member. And it's good to highlight you guys and your accomplishments. It's a really good time. Yeah. Nominate somebody. Like it says on the slide, you'll be featured on the Instagram and LinkedIn. That's the QR code. Please feel free to scan it. And yeah. Okay. Malik, do you want to do this?
Why I'm there?
Because you're the ops lead.
All right, so quick announcement about the junior ops. Okay, yeah, sorry about that. So yeah, junior ops and junior tech lead will be closing tonight. So please apply if you are interested. There's no expectations, no level of experience you should have. It's for everyone, and especially for our freshmen. If you are interested, please apply.
Malik and Alex are good people. You guys should apply. Okay, so this week we'll be having core services by Malik and Sartak, aka Smash 8 Tap. Everybody give him a round of applause, please.
Hello. All right, yeah. Hello again. It's us. Today we'll talk about the core services and about a little bit about who am I. I'm Malik, the ops lead, the ops program lead, and ops IG lead. I love ops so much. Senior BSMS students. Hopefully this is my last year. Interest home labbing, DivSec ops, digital forensics, threat hunting, and purple black teaming. XCPTC and current Himayah consultant. And here's my information. If you want to reach out to me about anything, please do.
Hi everyone, I'm Sarthak, or everyone likes to call me Smash. And I'm a second year MS Computing Security student. Probably this is my last year as well. And my interests include a lot of offensive security and red teaming stuff. And I also love ops. And I'm a big Vim enthusiast, so if anyone of you want to talk about Vim, let me know. I can teach you some stuff, or you can maybe teach me. And I also love home labbing, and I love to do a lot of CTFs, not really getting time lately. because of CPTC and also because of RWAP and ops. But if you want to reach out to me, there's my hashtag on Discord.
All right, so if you have not noticed, this presentation is sponsored by the Ops program, so we are cool, so cool. All right, so our agenda today will talk about core services. What is a service? Common services will cover some Linux services, Windows, networking, and other cool technology that you should know about if we have time for it. Hopefully we should. So, quick show of hand, who can define like a service? What is a service? Yeah, Anthony, what is a service? Okay, a service is a thing that does stuff, according to Anthony. But what is a service? A service is software to perform automated tasks, respond to hardware events, listen to for data requests from other softwares or other end users. It's usually loaded into the operating system and start up by itself, and it's run in the background, so there is no user interaction. A server just run without you knowing exactly, unless you go and find it, or you actually enable it. So a server is just like a piece of program that does not interrupt you at any time. So we're gonna talk about some other services that we have for Linux, and one of the first few is Telnet. Telnet is a type of protocol that enables one computer to connect to another computer. And that will be why I should do that, why I would need to connect to another computer from another computer. So, for example, you have a host on a network and they have a server. The server does not have a GUI, does not have a keyboard, does not have a mouse. So how are you going to control that? You can use Telnet and just have a remote code execution on it and execute commands on the system, or for debugging purposes, troubleshooting, whatever you want to do on the system, you can use Telnet. But there is one downside of using Telnet, which is it's everything transmitted through the internet or through the network in plain text. So if you ever had like any command that you do on the system, everyone should be able to see it in plain text, and I can know exactly what you do. How can this be bad? So if you just see a wire chart capture of Telnet there, everything just show like for Telnet, so you can filter for that. And just inspect the data or right-click on one of the packets and do TCP follow stream, and you can see the full packet capture of that. So, for example, if you just log into one of your systems, you can see the password in plain text, and you can see the username as well. So you'll be able to compromise the system. So that is why you should not use Telnet, unless it is the only thing that is supported, and you make sure that is really closed environment and really localized and not exposed to the internet. So that is Telnet. All right, so if Telnet is bad, but I still need to connect to a system and do my troubleshooting, debug, run commands, configuration, whatever I want to do, what I'm going to use. There is another secure thing that's called Secure Shell, which is SSH. And SSH is a secure network protocol to access remote computers in a network. And it has multiple authentication schemes, but I'm going to talk about the most famous two, which is password authentication and public key authentication. Password key authentication is still good and secure, and it's fun to use it, but it's not the recommended way of using Secure Shell, which is SSH. The recommended way of using that would be using public key authentication. So as we can see in the diagram in here, it just creates a secured encrypted channel between you and the remote server, and you just can access the data, and everything will be transmitted encrypted. So no one should be able to see your password, what commands you're running, and why not. We talked about the password authentication. We can just give a username and password, and you would just be logged in. But what about the public key authentication, which is a private public key authentication process? So the client has a private key and gets its public key to the server, and then the client initiates the connection, and the server will respond with a random message to tell the client, yeah, if you claim who you are, then encrypt this message with your private key so I can decrypt it with your public key that I already have. So if the message match what I sent you, then you like pass the authentication process. So the server will send like a hello there message, which is a random message. The client will encrypt it, send it back to the server, and the server will decrypt that using the public key of the client. And if the authentication passed, the client will grant access and start their like shared key and encrypt every traffic that comes through the client and a server. So this is the key-based authentication. If you can see, this is like how a Wireshark capture. It has its own protocol. So again, you can filter on that and see like who's connecting to what, and you can do further debugging if you have some fancy shenanigans you want to do. But yeah. All right, so we now talked about how you can access a remote system and configure it and just do whatever you want on the system. So how if I would like to transfer a file? I want to get a file from location X to location Y, and assuming there is no Google Drive, there is no email, there is nothing in there. So I want to transfer configuration file, private files, whatever file you want to transfer. So we use something called File Transfer Protocol, which is stands for FTP. And FTP is a protocol that is used for transferring a file from one location to another, i.e. from one host to another host. And that is what is FTP. The connection between the two hosts, clients, and the server is not encrypted. So we have, again, we have the same problem. Whenever those services or these protocols got designed, security was not in mind. So now security is getting more into of a thing, and they start to take security into their design. So for the starters, FTP is not secure again. And we have two different modes in FTP. We have active mode and we have passive mode. And we're going to talk about both of these modes. Yep. So what is active mode? Clients establish the connection and the server will establish the data channel connection. That does not make any sense, I know, but I will explain that in a minute. Both command channel, for the passive FTP, both the command channel and the data channel are established by the client. By the client. That does not make any sense, but I have a diagram in the next slide that will explain a lot. So if you can see, I know it's a terrible one, but this is what I found in Google. So active FTP, there is two channels that we should take care of. There's a command channel and there is a data channel. The command channel is where the client will send command to the server, say like, yeah, can you get me this file? Can you put this file in? Can you upload this? Can you download this? And the data channel is where the data getting actually transferred to the other end. So for the active FTP, the client will connect the command channel and the server will connect to the client for the data channel. So it starts transferring the data into the system. For the passive FTP, both of those channels are established by the client. If you can see the arrows, let me just use the mice, yeah. If you can see the arrows, this is established by the client and this goes back by the server. And in the passive FTP, we can see this is started by the client and this is also established by the client. One of the downsides of using active FTP, the data channel will be established by the server on a high random port. High random ports mean that a port is above 1024, I guess, right? Yeah, that is what is a high port. So if that gets established and if there's a firewall in the middle, that traffic might be blocked and we will not get our file transferred. But we still have the same problem. FTP is encrypted, and we need something that can stay with security. Now it comes Secure File Transfer Protocol, SFTP. SFTP offers some basic functionality, same basic functionality as FTP, but it uses tunneling and perform transfer over SSH. SSH is the cool, secure shit that we use, and now we're going to use it to transfer files, which is different from FTP's client-server and direct transfer approach. The connection between the two host client and the server is encrypted, which is we all care about. We care about our privacy, our data we're trying to get there, and everything about our systems. So SFTP, a client, for example, wanna get a server. A client would like to get a file from the server and will ask the server, "Can you give me this file?" The server will say, "Yes, I can give you that," and it will encrypt the process, encrypt the file, send it over to the internet, and the server will get it, decrypt it, and get it into the system. So it's the same process where you just ask for a file and you get it back, but it would be encrypted, and you have to do the encryption and decryption process, whether which way is sending what. But this is a high view of what is SFTP. You want to take this, or I can keep going? All right. VNC, virtual network computing. So when we talked about secure shell and telnet, both of those are command line based, but sometimes you want to see what is exactly happening with the system. You want to see a graphical interface, you want to see a GUI, you want to see whatever you want to do. So for example, let's have this scenario. You are an IT person that's trying to fix an employee's machine, and they've been asking you for help about a problem they cannot like access Google. Whenever they access Google, it just fails. So I need to see what is exactly happening on your system. So I can just use VNC and access the machine, see what you're exactly seeing, and get that graphical interface to my end. And I can control your mouse and keyboard. So any commands I will do, it will reflect on your machine as well. So we can both see the same shared channels. To make it simple, have any one of you used what is it called, TeamViewer, or know about it? Yeah, so it is exactly the same thing of TeamViewer, but it's not TeamViewer exactly, but you get the idea behind it. So VNC is a cross-platform sharing system that was created to remotely control another computer. Keyboard and mouse can be used by a remote user. One session, i.e. the remote and the local user will see the same thing. So whatever the user will see, you will see it exactly, and whatever the remote user will see, the user will see it. So you cannot actually scam them if you intended to do that maliciously, but yeah. Support multiple operating system. It has support for Windows, Linux, Mac OS, and it loves every operating system. It's not specifically made for one of these systems. MySQL, I will go.
So MySQL service is a service which is used to store data at the back end, and that data gets interacted with other application services, which makes use of that data which is stored in the database, and it uses by using a query language called SQL, or structured query language, that you guys might know about, and it basically stores user credentials and, let's say, blog articles. And so this kind of data can be pulled from the database during the runtime of a website. So usually some other applications like a website would pull data from the database. And it's listens on port 3306. And you can interact with the SQL client. So here's an example query. So you're trying to select an article from blog where author is Malik. So in this case, the column that we are getting is the article column, and the table is blog, and the value that we are checking against is the Malik. So next service is remote desktop, or RDP. So this was developed by Microsoft, and this protocol is used to provide GUI access to a system remotely. You might have heard about RDP in other scenarios. So Linux also can support RDP, but Microsoft proprietary developed RDP, and you can access RDP using various clients like Windows RDP client, which comes built in with Windows these days. And there's if you're trying to connect via a Linux system, there's other options like Remina. And if you are a terminal geek, there's RDesktop and X3RDP, which is my favorite. And it runs on port 3389. So DNS, next is domain name system. So what is DNS? It is used to resolve domain names to IP addresses. So whenever you enter google.com or any other website on your browser, the browser first, or your machine first, asks a device somewhere in the internet about what's the actual IP address, because computers don't understand what is a string and what does google.com means. They have to connect to each other using IP addresses. And the order of this IP address lookup is, first it looks in DNS cache, which is stored in memory. I think it's stored in memory on your local system. So let's say you're trying to go to google.com. Your system first will look into your memory and see if it has a hit against google.com. If it doesn't find that, there's a host file which is etc hosts in your Linux system and somewhere in Windows. Yeah, it's a host file, but it's in like system 32 Windows drivers. That's and then if it doesn't find it in host file, the next one is the ISP's DNS cache. So it tries to make a connection to your default gateway, which in turns goes to your ISP or internet service provider. We're gonna learn more about how this process works. There's different types of records. So A record, so whenever you try to make a DNS query, you can make different kinds of DNS query, and most common one that you would be doing is A or quad A, which is looking for an IPv4, and now we are switching over to IPv6 slowly, so these are the two most common type of records you would be making. There's other records like TXT record, which hides, which basically is used to store metadata information about your other network services, which sometimes is necessary to run those services, like mail exchange, like a mail server. And talking about mail server, there's also a record called MX server, which gets you information about a mail server. And there's much more. You can Google about it. And my friend here, Malik, will do a little demo time about DNS.
I don't know how Kenny has his. All right, so we were gonna do a quick demo, but Kenny, do you have any tabs on this? Can I click on the link or no? Can I? Okay, because it's his laptop, it's not mine. So whenever you have a problem and any networking problems, and you just wonder why, I usually go to a website called HTTPS is it DNS.com, and this will help you to debug any problem that you have. So if you just go to that link, it will tell you yes, any problem that you have, most likely, not always the case, but most likely it will be a DNS problem, and we hate DNS, or I do. But it is cool. It is a really cool thing. So that is about that debugging time. All right, keep going, Smash.
So now let's talk about how that DNS query works. How do we actually make those DNS requests? So there's two type of requests that you can make, or an actual server can make. One is recursive, another one is iterative. Then recursive is when you're the client on the left, and you try to make a connection to, let's say, example.com, and you don't have information about example.com in your host file and in your DNS cache. So what you do is you go to the recursive resolver, which most of the time is your ISP DNS, but if you're inside RIT, there's a dedicated server, DNS server inside RIT's WAN network, which does this operation. So what it does is it looks at your query string, which is the example.com in this case, and it looks at .com. So it's first going to try and see where is the network device which has the information about .com domain. So it goes to a root name server. It tries to find where can you give me the IP address of a server which knows more about .com domains. It comes back with an answer, and then it goes. So it tells you, okay, here is a server, which is this one, which has information about .com domains. Then it goes to that server and asks, do you have information about example.com domain? It gives back an IP address, and it asks, and it gives you the IP address, and it goes back to the next server in this chain. So you see how it recursively tries to find a domain's IP address. And finally, it gets to the last server, which has actually the IP address of example.com. This, in other cases, is also called as an authoritative DNS server, which holds the actual record to wherever you're trying to go. In contrast to iterative resolver, what it does is, so instead of going back and forth in this case that we had in a recursive resolver, what it does is it goes to the root name server, and root name server asks the TLD server, and it goes to the SLD name server. So it performs it iteratively, and the query comes back in this chain, and we get the request answer. So some common commands that you can use to use DNS and to find IP addresses is dig, which, so in this case, you can do dig on google.com, and you can specify a specific DNS server. In this case, I'm trying to query 8.8.8, which is the Google's own DNS server. You can also give RIT's DNS server in this case, if you know the IP address. And at the end, I'm giving a specific specific DNS record, which is IPv6 or Quad A, and it comes back with a IPv6 answer. In this case, in the screenshot, I have a TXT record, but you get the point. You can do the same thing with NSLOOKUP, which comes by default on Windows machines. And in this case, you can specify, so in my screenshot, I'm specifying the server as 8.8.8, and I hit the enter key, and then I can specify a type as, again, the different kinds of records that we have. So in this case, I'm trying to query a record, and then we can just specify the domain, and it gives you a bunch of IP addresses. Now let's talk about web services. So web services basically serve static web pages. Web pages are basically just files that you can interact with and access over the internet. Most likely, or most of the time, it would be HTML, PHP, or JavaScript files. Web services can do these two interesting things called as virtual hosting and reverse proxies. We're not going to be talking much about virtual hosting, but basically what you can do is you can host multiple domains within the same computer. So let's say you have rweb.ritsec.club, and also you have flags.ritsec.club. So both of those things can be hosted from within the same machine, within the same IP address and the port. Reverse proxy also provides a similar kind of feature, and we're going to be learning more about those in the next slide. But some common web services are IIS, which runs on Windows. We have Apache and Nginx. These are the most common web services you will find and work with. So let's learn about proxies. What is a proxy? So most of you might be familiar with proxies, like a forward proxy, which basically makes a request. So maybe you're trying to access some sussy website on the internet, and you want to try to mask yourself. So you'll go to these web proxy sites on the internet, and what happens is those machines are going to make a request on your behalf to the actual endpoint, so that the actual endpoint does not get any logs related to you. But this forward proxy will be getting all the logs that you're trying to make a request to this, so it's not really secure, and most of the time it's not encrypted, so it's not really secure. But basically, you are on the left side, you're trying to go to a resource server over the internet, and someone else in the middle tries to make a request on your behalf. Looking in a more bigger perspective, in bigger organizations, this is used to filter traffic. So let's say some organization don't want you to go to facebook.com, they'll just put a forward proxy in their environment, and all the requests will be going through that forward proxy, and they'll inspect the IP addresses that you're trying to go, and if the IP address corresponds to facebook.com on your work environment, they'll just drop it or block it. Now let's talk about reverse proxies. So looking at this picture, all we do is we just flip this internet back to here. So we're trying to connect to a server, and instead of directly connecting to the server over the internet, we connect to this reverse proxy endpoint, which will now redirect the traffic based on where you're trying to go. So let's say you were trying to go to rweb. So let's say this is rweb.ritsec.club. I'll use the mouse pointer. So let's say this was rweb.ritsec.club, and this was flags.ritsec.club, and you made a request to rweb.ritsec.club. So this reverse proxy will look at the string, and it's going to see you're trying to go to rweb, so it's going to redirect the traffic all the way over to this first server. So it basically performs some kind of load balancing, and it also provides you security because you're not directly exposing your internal servers onto the internet. And also, you're just exposing one port to the internet, which would be, let's say, 443, and then that can redirect traffic to multiple endpoints within your network. So this will also help you manage your web servers, because in this case, you'll just have to create one certificate for that web proxy, the public-facing web proxy, and you don't have to worry about any of these servers. But in that case, if you're using a web proxy with a certificate on your reverse proxy, what will happen is the traffic between the reverse proxy and this will not be encrypted using TLS certificates, because the TLS certificate sits on the reverse proxy. So all the traffic from your endpoint to the reverse proxy is going to be encrypted, but after that, it's not going to be encrypted. So you just have to take that in point.
So just to add one more note, if we see the forward proxy and reverse proxy, the forward proxy is concerned to protect the client, which is the user, which is us. But the other way around in the reverse proxy is more concerned to protect the service that we're trying to connect to, the resource that we're trying to reach. So this is one of the main differences that between a reverse proxy and a forward proxy.
Right. Thanks, Malik.
Yep.
All right, moving forward, we have the DHCP service. So whenever you try to connect to the internet, you first are trying to connect to a local access point within somewhere in your building or somewhere in your apartment. And whenever you do that, you get an IP address from that access point, or let's say your Wi-Fi access point. And traditionally, this was like way back in 90s. This was done manually. You were giving out IP addresses per machine manually, and that was definitely not the way to go because it's too slow. And what happens when someone disconnects from the network and that IP is just sitting there and no one is using it? So this idea came up called DHCP, which is Dynamic Host Control Protocol, which assigns IP addresses to your devices automatically. And it does this magic by this process called DORA process. Don't ask me how I got that acronym. So the first part of that process is DHCP discover, which when the client, let's say my machine, I'm trying to connect to the internet, first tries to find a DHCP server inside the environment, and it just broadcasts everywhere inside the network environment about finding where's the DHCP server, how can I get an IP address on this network. After it does that, if there is a DHCP server running in your network environment, it's going to send in an offer back to the client, back to my machine, and it's going to tell me that I can offer you this IP address. And then the client makes a decision, do I want this IP address, or maybe I had a previously assigned IP address that I want to use. Based on that, it makes a request back to the DHCP server, and the DHCP server makes decision if that IP address is available or not. If it's available, it sends back an acknowledgement to the client, and that's how the DORA process gets completed, and you finally get assigned an IP address, and then you can talk on the internet. Mail service. So it's a very basic mail service where a server is listening onto your mail requests, and it processes your mail requests, inspects the target request or the recipient of that email. It looks at that and makes a decision where it has to relay that email, that message. And once it does that, it relays the message to the corresponding server. Then the recipient server, in this case Tom's incoming mail exchange server, will look at the request. It's going to download the message, and it's going to put that into your recipient's inbox. So very basic. And the SFTP server listens on port 25. All right, Active Directory. So this was developed by Microsoft, and this was first released with Windows 2000 Server Edition, and then it got support for Windows 95 and older versions of Windows. So basically, it lets clients' machines on the network to authenticate and authorize over a Windows network, and it also supports single sign-on. So whenever we talk about Active Directory, it comes with a lot of services, and I've just mentioned 3. There's tons of more services if you have set up an Active Directory domain controller, because inside that domain controller you'll see a bunch of services mentioned. But some common ones are the domain services. Then there's LDAP service, which is basically the directory access service, which lets you store information. And we're going to talk more about LDAP in next slide, so I'm not going to spoil. Then there's certificate service, where client and server authenticates to each other using a certificate. Active Directory is really hard to manage and even harder to secure. You might know that if you come to RWAPT, which is, by the way, is on 7:30 on Tuesdays. So let's talk about one of the services that we mentioned, LDAP. So LDAP service basically stores all the information about your network, your users, and files in the domain, in the network, and computers on a domain in a nice direct tree-like a format. So if you see here, we have a tree where we are storing information, let's say about our servers in an object. So it's basically like gives you a nice way to organize your data into directory tree structure so that it can be contacted by the Active Directory domain controller nicely. So there's some LDAP tools that you can use to carry this information, such as LDAP search and RPC client. I have a screenshot. You don't have to deal much with LDAP search if you're not really working with Active Directory, but you can learn more about these tools online. So whenever we talk about Active Directory, one thing that comes into our mind is the Kerberos, which is the actual authentication protocol. But this was developed by MIT in 1988, and it is open source. But what Windows uses, it is closed source version of Kerberos, which basically has same steps. And it provides mutual authentication, meaning both the client and the server authenticates to each other. And it also provides you single sign-on capabilities, and it uses symmetric key cryptography. So let's now understand how does a client authenticates on a server and accesses a service. So let's say you are trying to connect to IIT's network and you wanna access the FTP server on the network. So how does that happen? So you initiate your connection. So on the left, you initiate a request, and you enter in your credentials, and that gets sent to the Windows domain controller, which is like a big giant domain controller. And it has all the information about users and their passwords, and obviously in a hashed format. So it authenticates and checks if you are allowed to log into this domain or not. Once it confirms you can log in, it sends you a ticket. So this ticket can be thought of as a Disneyland ticket that you get once you enter a Disneyland. And once you have that ticket, you can go around the Disneyland and show that ticket and access any of the free rides, or not free, but rides. So once you have that ticket, you can go back to domain controller, and you can ask that I want to access the file transfer protocol server. So on the step 3, you take that ticket, you ask the domain controller that I want to access an FTP server, and it gets you a session ticket, a short-lived session ticket, so that you cannot just ride unlimited times. So this gives you a session ticket, and you then go back to the FTP server, and then you can provide the session ticket and access the source. Now let's talk about Samba. So we talked about a bunch of different file transfer service. Samba is one of them. This is an open source version of what you might have heard as SMB, which is Microsoft's proprietary implementation of Samba, and we support open source, so that's why Samba is here. And it basically provides you file and printing services, so you can share files over the network, and also you can get printing services. And now it also has Active Directory support, so you can actually connect your Linux boxes to an Active Directory domain controller. Fun fact, the word Samba was derived by running grep command on the file system. So they just ran grep-i, which is case insensitive, on the file system looking for anything. S ** means anything M and B, and then they found Samba, and that's how the name came. So some of the tools that you can use to access files is the SMB client, which comes on Linux systems. So the way to do that is you provided 2 // and then the IP address, and then the flag, or whatever the name of the share is, and then you provided a username. And once you do that, it's going to prompt you for a password, and once you get that, you can access the files just as you would do it in an FTP server. An easier way to do that is using your Windows File Explorer. You just do \, 2 backslashes, and then the IP address, and then the share name. And then it's going to prompt you for username and password. WinRM. So Windows Remote Management is a service which allows you to access management services over the network. But we here, during the competitions or during red teaming, we use it to execute commands remotely on a system. And one of my friends yesterday wrote a script which can execute commands over the entire lab network using this protocol. So this is basically an SSH connection. You can think of it as an SSH connection where you can execute commands on remote machine for which you know the password, obviously. And it uses, on the back end, it uses HTTP protocol. Also, it can use HTTPS, and those are the ports mentioned. And to use it, we provided WMIC, which is the command we use in Windows. And /node is the name of the computer on your local environment. And then you give it a module name called process called create, which basically runs the command, whatever you give it after that on the remote machine. Let's see how much time we have. We have 15 minutes. So we can talk about other cool technologies that you should.
All right. Okay. Yeah. So we finished with the main core services. There's a lot we covered in the core service, but there also are some cool services or cool technology that you should know about. It's really essential for everyone to at least have a basic understanding of those, because this is the future for every position that related to computer in general. So we're going to talk about Docker. And what is Docker? Docker is a set of platform as a service, which is referred as PaaS, product that use an OS level virtualization to deliver software in a package called containers. So we can call them baby VMs. It's a really tiny VM that can ship to your computer and run on, and you have a standalone operating system or a service that you want to run. So containers simplify the development and delivery of distributed application. So if you have an application that you want to ship to your friend, for example, I have my own website in a Docker container, and Smash just asked me, Malik, I like your website, can I have it? I just ship that Docker container to him. He will run it, and he will have the exact same copy of that. So it's really amazing to ship like specific services, a specific functionality that you want to get across to everyone, and contribute to the open source community, or just create your own standalone application. For example, we talked about Nginx, Apache, REST proxies, and many other cool services. All of those are available as a Docker containers, where you can just download them and interact with them, and you can have an Apache like a web server that's running on your system in a Docker container, and whatever changes that you do, you can just zip this file, or not zip this, I take this file out and send it to your friend, and your friend will have the exact same copy of your website. So it is really amazing to use. So I talked about Docker and how it is a baby VM. As we can see, a VM is an operating system that runs a virtualization solution such as VMware Workstation. And then you have an ISO file, you give it RAM, you give it CPU, you give it hard disk storage, and it creates a VM for you, and all of that can be resource intensive. So for example, you will not be able to run on an 8 gig RAM like 4 or 8 VMs. It will be a resource intensive, and that would not be handled easily by your OS or by your computer. On the other hand, you can virtualize those services as Dockers, and Docker is a really lightweight, resource efficient, and whatever you call it, it's a really amazing service that give you the ability to run a single service on a single VM, or like a light VM, a lightweight VM, where you don't have to give it like a huge amount of resources or any huge amount of networking capabilities, or whatever you want to call it. So as you can see, if you consider the 8 gig RAM computer that you have on the right side, you can see you will be able to run at least 3 VM, or at most, 3 VM, but on the Docker containerization, you will be able to run multiple applications, and all of those will not cause any interruption for your operating system itself. We have also this meme. When it works on my machine, I can just ship it back to you, and it will work on your machine also. So it does not depend on any like pre-installed resources or anything. I will just give you the Docker container. The Docker container will virtualize an operating system, download everything that it will need, and then that will just run. So if it works on your machine, it would work on others' machine, hopefully. So what is the pros of using Docker? Why we should use Docker? Lightweight, improved developer productivity, greater resource efficiency. As we mentioned again, it's really use minimum resources, so it will not eat all of your CPU power or like RAM power or storage or whatever you call it. So there are some tools and terms that you should know whenever you interact with Dockers. The Docker file term is every Docker container start with a file, and that file defined an OS. An OS such as like Ubuntu or npm node or different resources that you can use for those Docker file. So everything is started with a Docker file, and the Docker file defines the environment where your application would run. Docker images is an image that has pre-configured or predefined values or application or services installed in it, and you can just get this image, run this image, and you will have the service up and running. Docker containers is what is the actual protected level of the application that you're trying to do. So if I want to give you a Docker container, you expect that to be functional and work as expected or advertised. Docker Compose, when you want to build different application or like a huge application based on Docker, and that will use like multiple Docker images or Docker containers, you can just compose all of those into one file and ship this file, and that file will get built on the other operating system. So this is Docker, and we'll talk about CI/CD. Do you want to go? Okay. CI/CD stands for continuous integration, continuous deployment or delivery. So whenever there's a huge project in your environment and you keep pushing code, keep patching stuff, adding updates, adding more functionality. So what does that mean? You will push your code to a GitHub or whatever example you have, GitHub, GitLab, or whatever version control you use, and that code will be run into like a CD pipeline that will get clone this code or pull these changes, build those and test it and make sure it's like running as expected. There is no errors, there is no failure, and if it's passed, then it will get pushed to the deployment or the development, or not the development, to the production. Sorry, yeah. It will get pushed to the production environment, and your code should be up to date in every system. So automate the build and test steps triggered by CI, which is the continuous integration, ensure that code change made being merged into the repository and reliable. So whatever change that you made is not causing any troubles in your system. So test it first and then integrate that to your version control history. And after that, it will just get pushed to the CD environment. So the code is get delivered quickly and seamlessly as a part of the CD process. So your code will get pushed to the production level. We have a nice graph here where the developers commit changes to the GitHub repository. And from that, it will get built, test, and deploy. And if it's passed, it will just go to the production, as we can see in the down area here, or the bottom area. And if it's failed, it will just get back to the developer. Says like, yeah, I was not able to build it, so your code is not working as expected. So the developer can make a new commit and like make new changes, make it working, push it again. It will get built, test, deployed. If it passed, it will just go again to the production. So CI/CD is a huge term. Everyone is using it now, and you should at least read about it. And if you ever have a question, you can ask the ops program, because we're cool. That will be our educational talk. So thank you so much all for coming. And if you have any question, please ask them away.